Welcome to my channel, Department of Chemistry, University of Kashmir. Today we will discuss the mechanism of relaxation processes, which are spin-spin relaxation and spin-lattice relaxation. In the last video, we have discussed what are the relaxation process and what are the factors that are responsible for relaxation process. Today we will discuss the mechanism of these relaxation processes. There are two relaxation processes. One is known as spin relaxation and second is known as spin-lattice relaxation, and as I have already told you in the last video. First we will discuss the spin-lattice mechanism of spin-lattice relaxation. After that we will discuss the mechanism of spin relaxation. So let us start. Mechanism of spin lattice relaxation. Okay, the mechanism of spin-lattice relaxation is known as nuclear dipolar interactions. Mechanism of this is known as nuclear dipolar interaction. What is nuclear dipolar interactions? I will discuss. Suppose I have a sample. This is our sample whose NMR we are going to do. This is our sample. Okay, this sample contains molecules, electrons, ions, atoms. Okay, but we are interested with the hydrogen nucleus, so we will discuss those molecules with which the hydrogen nucleus is associated. This sample contain molecules. Okay, these molecules contain hydrogen nucleus, hydrogen atoms, or hydrogen nuclei. Okay, as we know, this hydrogen nucleus is associated with the magnetic moment, but in our sample these molecules are not in the rest. They are continuously tumbling. Tumbling means they are continuously rotating. Tumble is the meaning of tumble is the rotate. These molecules are continuously rotating. What happens by this rotation? What happens? The hydrogen nucleus, the magnetic moment associated with the hydrogen nucleus is continuously fluctuating. That means their magnetic moment is sometimes increasing, sometimes decreasing. So by this tumbling, it will give rise a fluctuating magnetic moment at some frequency. That means magnetic moment is increasing, decreasing at some frequency. So we write, because why it is increasing, decreasing. Suppose this is our external magnetic field B naught. Okay, sometimes the hydrogen nucleus, the magnetic moment associated with the hydrogen nucleus comes in the direction of external magnetic field. Sometimes it comes perpendicular, sometimes it comes to the against. So okay, when it comes to the in the direction of magnetic field, its magnetic moment will increase. Sometimes when it comes against, its magnetic moment will decrease. When it perpendicular, its magnetic moment will be affected. So we say that due to the tumbling of molecules, it will give rise to fluctuating magnetic moment at some frequency. That means it is fluctuating at some frequency. But if our molecules, sample molecules, tumble with a frequency equal to the resonance frequency, okay, at resonance frequency, what happens at that time? This fluctuating magnetic movement of hydrogen nucleus are in phase with the resonance frequency. When it is in phase with the resonance frequency, the phase means that it matches to the resonance frequency. When it matches to the resonance frequency, at that time the higher energy state, spin and higher energy state, relax into the lower energy state and imparts its energy to the lattice as a rotational and vibrational energy. So I will write this first line by line what I have told you. I have written these lines. First, you take this. The mechanism of spin-lattice relaxation is known as nuclear dipolar interaction. Okay. Second is, since the sample contain molecules which are associated with the magnetic nuclei, okay, are tumbling. That means these molecules are continuously tumbling. Tumbling means they are continuously rotating continuously. It gives rise a fluctuating magnetic field at some frequency, okay. When the molecule tumble means rotate about at resonance frequency, what happens at that time? The magnetic field are in phase with the resonance frequency, or phase means they are or it means that when they are in phase, it means they match with each other. Or it means it matches. Resonance frequency. That means the magnetic field are in phase with the resonance frequency. Phase means, or we can say more simpler words, the magnetic field matches with the resonance frequency. Phase means matches. What happens at that time? When they are in phase, the upper nuclear spin relaxes into the lower energy state and imparts its energy as transitional and rotational energy. So it is about the mechanism of spin-lattice relaxation. Now we will discuss about spin-lattice relaxation time and width of spectral line, why we get the broad spectral line is NMR, and why we will not get the sharp peaks, okay. Suppose this is our energy state, higher energy state, or we can say like this. This is our nuclear plus 1/2 state, okay. This is minus 1/2 state, okay. This spin state has to relax into the lower energy state. This is alpha, this is beta, this is alpha, okay. Now this what is occurring in the spin-lattice relaxation? This higher energy state have to relax into the lower energy state and impart its energy to the lattice, okay. The time required, the time constant for the energy transfer from spin to lattice is known as a spin-lattice relaxation time. That means the time required for the spin state to dissipate its energy to the lattice or to transfer its energy to the lattice. How much, in which time it will occur, how much time it will require to do this process is known as a spin-lattice relaxation time, okay.